So if by now you've noticed that you're not all that comfortable with slicing and dicing of matrix-matrix multiplication and all of these different algorithms that come out, you may want to consider going back to our first massive open online course and looking at weeks 4 and 5, and week 5 in particular, because there we really talk about how to slice and dice matrix-matrix multiplication. There was a reason why we created that massive open online course first, is to give you a place to go back to if you don't quite remember some of your linear algebra, right? How else can we actually do this matrix-matrix multiplication? Well, the one algorithm that you may not have learned about views matrix A as a set of columns and matrix B as a set of rows, and then recognizes that you can update your matrix C by doing this times that added to the matrix, followed by this column times that row added to the matrix, followed by this column times that row added to the matrix. Okay, and how does that work more abstractly? Well, think of this as matrix C, which we're now not partitioning. We partition our matrix A by columns, A0, A1 through AK-1. Remember, there are K columns in matrix A and K rows in matrix B. Times B partitioned by rows. But remember, these are rows, so we add to the label that identifies the row the T for transpose to indicate that it's a column vector on its side, a row. And then we say, oh, but wait a minute, we saw A partitioned by rows before, and then we had to put a tilde on it to identify that it was a row and not a column. So that was a good thing that we did, because otherwise we might have confused ourselves with these labels right here. We have seen the labels B0 through BK-1 before, or at least through Bn-1. So just to make sure we don't get confused with those, let's put a tilde on these as well. And notice that we have to add to matrix C. All right? And then, we're back to, look, how you multiply with a partitioned matrix is exactly how you would have done it with matrices that have numbers in them, except now you do it with symbols. So let's think of this. This is like a vector 1, 2, 3 multiplying a column vector 4, 5, 6, a row vector times a column vector. How would you do that? This times that plus this times that plus this times that. That's exactly what you do with the symbols here. It's this column times that row plus that column times that row, etc. So you get A0 times B0 tilde transpose, row B0 tilde, plus A1 B tilde 1 T, etc. Okay, plus C, of course. And let's make that an equal here so that it's an assertion rather than a computation. Keep in mind, this is a column times a row, plus a column times a row, etc. And we looked at that operation carefully. That's a rank 1 update. And oops, I guess we forgot to put a hat on here. But what we're noticing is that we could compute this as a rank 1 update to C plus a rank 1 update to C, etc. Okay, and this is why we made a big deal out of the rank 1 update in week 4. All right, so how do we now get a partitioned matrix expression out of this? Well, we've given you quite a few hints. Why don't you try to come up with the partitioned matrix expression from what we've given you here?